Good afternoon, kids. Today in class, we started talking about the volume of our solids. And again, we're going to look at just a few today. We got a cylinder, triangular prism, and then we have a pyramid down here. So we just want to look at a few of these. Now, in class today, we're going to give a generic formula, capital B times H. And for most of us, we're probably pretty good here. All right, H is our height. We understand that. The capital B is the area of the base. So when it comes to calculating the volume, we're going to have a different formula based on what we're dealing with. Okay, these two formulas are not going to be the same. And then when we get to the pyramid, it's going to be a little bit different too. But it is based on the base of that particular shape. So if we start over here with our with our cylinder, okay, our base is going to be what shape? All right, the base is the circle. Okay, same circle here as on the bottom. Really doesn't matter which one you use, but remember the base, there should be two of them. Well, I shouldn't say that. All right, there's not going to be two of them in every shape. So base is a circle, so we got to find the area of the circle. So that's our formula, pi times our radius squared. So for this particular shape, our radius is 6. 6 squared. So the area of our base, got it. Now we need to multiply by the height of the solid. The height of the solid is 12. So a lot of multiplication here tonight. Remember, we can leave this as 3.14. 3.14 times 6 squared times 12. So I get a volume of 1,356.48. I guess I forgot to do. So this will be cubic units. I didn't label. So this would be cubic units. So remember volume, three-dimensional, cubic units when we label. So that's, again, telling us how much it would take to fill this drum up. 1,356 cubic units of water, whatever it may be. All right. So now we come over here to our triangle. Okay, same idea. Calculate the volume of our tent. How much space do we have inside this tent? We want to find the area of the base. Okay. The base is not defined as the bottom. Okay, the triangle is the base. The triangle is the base. All right, bases, there has to be two of them. They have to be parallel to each other. There's a triangle in the front and there's a congruent triangle in the back. Therefore, they're parallel to each other. We can define those as the bases. The bottom, there's not another one on top opposite that, so that is not considered a base. Okay. So that's what we got to keep straight is where's the base. And in this case, it's the triangle. So for that, our formula is 1/2 base times the height. Okay. So for our triangle, the base is 5, height is 7. So 1/2 times the base times the height. And then the last part of our formula is to multiply by the height of the solid. And how tall is this solid? Well, how far is it from triangle to triangle? That's considered the height. And for this particular one, it would be 8. Okay, we're using the word height loosely here. I know most of you probably don't want to consider this a height, but the height is the distance in between the bases. Okay, the distance in between the bases. I can draw this exact same triangle. I mean, here it looks like it's a tent, but I could draw the triangle standing up. Exact same numbers. Here's my 8, here's my 6, here's my 5, here's my 7. Okay, we got the exact same tent, exact same prism. This one's just drawn vertically, this one's drawn horizontally. We don't want to change how we look at the volume. This is going to hold just as much as this one would. All right, so when we define our height, okay, yeah, here it looks like a height of 8. Here it may not look like that, but this is still the same height as if it was standing up. Okay, so maybe if that's the way, maybe if that helps you, visualize the tent standing up. But that's our height. That's our height. So there's a couple formulas. We come down here to our pyramid. Same formula. Same formula. Area of the base. Okay, now where's our base? Well, it can't be this triangle because it's touching the triangle opposite. Can't be this triangle in the front because it's touching the triangle on the back. So all the triangles are eliminated from being a base. Therefore, the square is our base. Pyramids and cones are unique in that they come to a point. They come to a point. So our base is going to be that surface that we only see one time. Okay? So that's why we consider that the base. The height of a pyramid. Is the height of this pyramid 8 or is the height 6? Remember, height must be straight up and down. Okay? 8, if you remember from surface area, we would call that the slant height. So this ridge pole right here, okay, this ridge pole right here, that's the height we're looking for here. That's the height we're looking for here. So this is a 7 by 7 by 6. 49 times 6, 294. Volume of pyramids and cones, okay, we must divide by 3 for pyramids and cones. They are always 1/3 of the actual solid. 1/3 of the actual solid. So we need to divide our answer by 3. So we get a 98, I believe. 98 cubic units. So when you calculate volume tonight, instead of trying to overload you with a whole bunch of formulas, just remember it's the area of the base, whatever shape. This one, the base is a circle, so we started with the circle times how tall it is. This one was a triangle, started with the triangle times how tall it is, or how far is it in between the triangles? How far is it in between the circles? How far is it in between the square and the top? But since this one goes to a point, we got to divide by 3. As always, do the best you can on your homework tonight. If you have any questions, bring them to class tomorrow. Have a good night.